Okay, so welcome to this information session on PhD in the Communication Signal Processing and Learning Group, the Department of EE, IIT Hyderabad. So first, I'd like to just maybe talk about uh, the institute itself, give an overview of what facilities are available, what kind of research we do, and then go along. So we have roughly 600-acre campus, and it's located just outside Hyderabad. Here are some aerial views of the campus. And we have a lot of cutting edge facilities. The total number of faculty in the institute is around 300 plus. And we have a world class convention center where we host conferences and workshops on a regular basis, an international guest house, and um, a world-class library. This is the Knowledge Resource Center or the library of the institute. A very large lecture hall complex. Here you can see different views of the lecture hall, and these are the some of the classrooms and uh, seminar halls. And in addition to these, we have a lot of facilities for students, including hostels and mess. And so this is what the hostel area looks like. Um, and we have excellent sports and cultural facilities, including an open air theater and a large outdoor sports uh, center. In addition, for research and development, we have an autonomous navigation testbed, uh, which I'll talk about a little more. And we have a lot of innovation going on. We have two centers, the Technology Innovation Park and the Technology Research Park, where we have a lot of incubated companies. This is what the Department of EE looks like. This is our building, which is so it's a building for electrical engineering and computer science. Um, Here are a few views. So this is a brief overview of what the campus itself looks like. And so I'll maybe now talk about the research that goes on in our group. So as the name suggests, we work on all aspects of communication, signal processing, and machine learning, theory, algorithms, and systems development. Theory, we have a lot of cutting edge work on various topics ranging from security to information theory and coding to estimation and machine learning and optimization. Uh, we also develop a lot of algorithms, and there are a lot of contributions coming from the CSPL group, including waveform design for 5G and 6G, which has also gone into the 5G standards, and also algorithms for speech enhancement, autonomous navigation, visible light communications, digital twins, and so on, just to name a few. There's a lot of systems development that also goes on in the institute. So we have an indigenous 5G testbed, one of a kind autonomous navigation testbed that I briefly flashed earlier, and which also has an autonomous campus shuttle and deployments of massive MIMO. And systems development, we go all the way from, say, building uh, let's say, designing algorithms and toolboxes for image quality assessment to implementations on FPGA and hardware, all the way up to even building a self-driving car. All right, so here's a brief overview of the indigenous 5G testbed that I just talked about. This includes a, a lot of deployments or implementations of massive MIMO and so on. All of these have gone into the standards and an extreme massive MIMO demonstration. And in fact, an NB-IoT chip has been developed by this group, and a small cell base station, and so on. So it's not just that we develop algorithms; these are also implemented on hardware. There's also a test bed for autonomous navigation that we have on campus. So this includes a track where um, autonomous cars can be tested. There are drones, and so we have cars that are the autonomous, and we also have an autonomous campus shuttle, a self-driving campus shuttle that keeps running around the campus. Here's a very short clip demonstrating what we have. And we and the work that is done here is not just in isolation. This is also done in collaboration with various academic institutions as well as the industry. So there are collaborations from a lot of universities, including Stanford, University of Agder in Australia, France, USA, as well as government organizations and industries, including Qualcomm, Suzuki, Meta, and institutions such as LV Prasad Eye Institute. And we also get a lot of research grants from various organizations. So a lot of these projects are funded by organizations such as the Ministry of Information Technology, the Department of Science and Technology, SERB, and various companies as well. And a lot of our we're lucky that a lot of our alumni have done pretty well. This is just a short, I mean, only a short sample of where our alumni are and where they have been. So many of our past PhD students have graduated and gone on to do postdocs in the Netherlands, UK, US, Japan, and currently some of our students are faculty at places like IIT Indore, IIT Mandi, IIT Jodhpur, BITS Pilani, various NITs, and not just in India but also in abroad. We have faculty who are we have alumni who are currently faculty in the Netherlands, US, and Japan. Many of our alumni are also now working have a lot of positions in government or research labs, including DRDL, ADE, and so on. And of course, many of our former students are also in the industry in various companies like Qualcomm, AMD, Intel, Samsung Research, Suzuki, and so on. So we have about 15 faculty in the CSPL group in the EE department. And here's a quick profile of various people. These slides will also be made available later on, perhaps on our website, so that you can take a look at your leisure. So we have Professor Zafar Ali Khan, who works broadly on wireless communication, signal processing, and radar, and Professor Kiran Kuchi, who heads the 5G 6G testbed and who works on wireless communication and 5G and 6G standards. Professor Abhinav Kumar, who works on wireless communication and machine learning and the interface between the two, and Professor Raj Lakshmi, who heads the TIHAN or Autonomous Navigation Testbed, who works on IoT, autonomous vehicles, drones, and so on. Professor Soumya Jana, who works broadly on biomedical signal processing, statistical modeling, and information theory. Professor K. Sriram Murthy, who works on speech processing and more broadly signal processing and machine learning. Professor Sumohana, who works on image and video quality assessment and machine learning more broadly. Professor Sundaram Manka works on integrated sensing and communication networks, and including non-terrestrial communications for 6G. We have Dr. GVV Sharma, who works on wireless communications and wireless networks, and also works on implementing cryptographic algorithms on hardware. Professor Lakshmi Prasad, who works on coding techniques and information theory, and has recent work on codes and sequences for 6G communications. Professor Aditya Siripuram, who works on signal processing and Fourier analysis, and recent work on DFT computation. Myself, my name is Shashank, and I work on information theory and coding and its applications to data compression and machine learning. Professor Maina, um, who works also on coding and information theory, more broadly distributed storage and Wi-Fi systems. And Professor Shashi Vinay works broadly on wireless communications and recently is working on ISAC, integrated sensing and communications, and OTFS. Professor Anjana, who works on codes and modulation for wireless communication, and including codes for distributed computing and 5G communication. So this was a very quick overview of the kind of diversity and depth that we have in terms of research in our group. So now I'll maybe briefly talk about the selection process itself, about the PhD program and the selection process. If you want to know more about faculty and the department in itself, you should take a look at the department webpage, ee.iith.ac.in, where you can also get more details about faculty and publications and so on. So what is it that so ultimately you're all here because you want to do research in communications and signal processing or learning. And what do you need to be able to effectively do research in this particular area? You need theoretical foundations. No matter what you're working on, what area or what topic you work on, you will need to master your basics. And for that, you'll go through rigorous coursework, particularly on aspects of mathematics. Probability and linear algebra are fundamental to any uh, research in communications or signal processing or machine learning. And you'll also be taking courses on the basics of digital communication, signal processing, and courses on machine learning and deep learning. And if ultimately it's not enough to just know the basics, you have to be able to design and implement algorithms. And this could be, let's say, programming in Python or C++, or implementing those on FPGA. So ideally, good research involves not just theory, but also algorithm development and systems development. And this could be development of prototypes on hardware and software. It could range from an FPGA to something a lot more complicated. But in the end, you have to not just be able to do all of this. In order to do this effectively, you have to be able to stay up to date with what is going on in the field. So you should be able to effectively read and grasp papers and research articles. You should also be able to communicate your work effectively, and that involves writing a lot of papers, writing them well, and also give effective presentations. But but uh, at the heart of it, what you need is you should be able to do hard work. You should have the motivation, you should have the passion to work on one problem deeply. You should take the initiative and also have consistency in your work ethic. So typically a PhD would look something like this, particularly in our department. You first, let's assume that you have been admitted at the institute. The first step is typically to do your coursework and choose an advisor. Now there are two ways of joining. There are different sources of funding that you may get as part of your PhD, and this will be clear to you when you receive your admission letter. The first, if your PhD is going to be funded by a particular project that is funded by either industry or a government agency, then usually your advisor is fixed at the time of admission, because it will typically be the person to whom the project is awarded to. But most other sources, so if you're an MOE sponsored candidate, or you come with your own source of funding, such as UGC or you're self-sponsored, then typically you get around one semester to choose your advisor. The first year is typically um, about doing coursework and literature survey, get your feet into research. And at the end of 1 year, you'll have to give something called a comprehensive exam to test your basics. And then you carry on, you do some more research, you try to formulate a particular problem, and within 2 years, you are expected to formulate a problem that you're going to work on, do some initial work, and you'll have a research proposal seminar wherein you talk about your problem in front of a panel, and the panel gives you feedback about the kind of research that you plan to do. And then you publish papers and so on. And towards the end of your PhD, when you and your advisor feel that the work that you have done is enough to form a good thesis, you first give what is called an open colloquium. This is a presentation that is given to that anybody is open to attend, and then you collect your feedback and then you submit your thesis. And the thesis typically goes out for review. And once the thesis is reviewed and accepted by the reviewers, if the reviewers are satisfied with the work that you have done as part of your thesis, then you finally give another presentation called the defense or the viva voce. So this is what a typical PhD looks like, not just here, but most parts in various other institutions as well. But in order to get there, we have an admission process, and the admission process looks somewhat like this. So first, you submit, you apply to the department. There's the online application process, and based on your credit, based on your let's say gate score or marks that you have scored as part of your UG or PG, there'll be a preliminary round of screening, and then there'll be a written test and interview. The written test and interview will be held maybe in 1 or 2 days consecutively. So if you clear the written test, then on the same day or the very next day there will be an interview. And if you do well at the interview, then you'll be shortlisted and you'll get an admission. Right, so this is the high-level admission process. The written test, the dates for the written test and all of this will be announced later once the application dates have ended and so on. And the written test will mainly focus on basic aptitude, which includes like very basic mathematics, calculus, and combinatorics, some linear algebra and matrices, and probability and random processes. So this is foundational. These are the minimum basics that are expected or required in order to do research in CSPL. So the written test will essentially focus on just these three: the basic aptitude, linear algebra and matrices, and probability and random processes. The interview will have a slightly broader scope. Again, the emphasis will, a good part of it will still involve basic aptitude, probability, and linear algebra, but it will also include questions on communications, so signal processing, or machine learning, depending on where your interests lie, and some amount of programming aptitude as well. And both in the written test and the interview, the focus will be on how well you have understood your basics and how you think. So the interview will also focus on the approach that you take to solving a problem rather than just getting at the final solution. Because after all, research requires you to solve problems that have not been solved by anyone before. So the way you think matters more than whether you're just able to get the solution. And it's also important to be able to look at a problem from different angles because that is how you innovate. All right. So just to give you a sense of what could be expected in the written test and the interview, here is sort of an example question. It's a very basic question in probability. So let's take a look at this. So the problem is as follows. You have an unbiased coin which is tossed twice. Suppose that the first time it is the outcome of the first coin toss is X, and the outcome of the second coin toss is Y. And I define another random variable Z, which takes the value 0 if X is equal to Y, and Z is equal to 1 if X is not equal to Y. So the kind of question that you could be asked is, what is the probability distribution of Z? Are the random variables X and Z independent? And what happens if instead of X and Y being the outcomes of two coin tosses, what happens if X and Y are outcomes of the rolling of a fair die? Right? So let's maybe go over these questions one at a time. And also I'll walk you through how one would need to think about this particular problem, or one way of thinking about this particular problem. The first question was, what is the probability distribution of Z? So we want to find since z can take only two values, z can either be equal to 0 or z is equal to 1. This is a Bernoulli distribution. So it is enough to find out what is the probability that z is equal to 0. So the probability that z is equal to 1 is simply equal to 1 minus the probability that z is equal to 0. So how do you compute the probability that z is equal to 0? How do you think about this? Well, z is equal to 0 if x is equal to y, and z is equal to 1 if x is not equal to y. So you need to find the probability that z is equal to 1, right? And that essentially is uh, you can, one way to do it is you list the outcomes. In this small toy example, you can try to list all of the outcomes which correspond to x equal to y. So for example, x and y can both be equal to 0, or x and y can both be equal to 1. So there are two sets of outcomes, x equal to 0, y equal to 0, and x equal to 1, y equal to 1. And then you can compute the probability of this, right? And that will give you the probability that z is equal to 0. So that's one way of thinking about this particular problem. The second question is, okay, are x and z independent of each other? So first, the question that you should ask is, do you really understand the meaning or definition of independence? Right? More than just getting the solution, it's important that you understand what is meant by dependent random variables and independent random variables, and whether you can apply that particular definition of independence to this particular problem. So one way of checking for independence is that the conditional probability that z takes a particular value little z, given that x takes the value little x, should be equal to the probability that z equal to little z, and this should happen for all possible z and x, not just for some particular values of x and z, right? And you can and basically you have to check that this indeed happens for all z equal to 0, x equal to 0, z equal to 1, x equal to 1, z equal to 0, x equal to 1, and so on, all four combinations, right? But so this is something that you can solve pretty easily, but then for example, in your interview, you may also be asked the following question. So it's not just important to be able to solve this particular question, you should also understand what are the basic principles, and can you use those basic principles to solve a more general problem. So for example, what happens if x and y are outcomes of rolling a fair die? Right? So given that you know the solution to this problem, can you approach a more complicated problem? And what steps or what insights from the old problem you can use to solve this more complicated problem? So for example, for what other distributions of x and y can we have x and z to be independent of each other? And you should think about, can you explain why? It's not just enough to tell the answer, but you should also be able to justify your answer. So for example, can you find an example where x and z are actually dependent and not independent, right? So this is sort of the way you need to think and what is typically expected in the written test and the interview. So another question, for example, from linear algebra is the following. So suppose you are given m linear equations in n unknowns, then you can ask two questions. If m is strictly less than n, is the number of solutions infinite? If m is greater than n, then do we have no solutions at all? Right? Is it always true that for every set of m linear equations in n unknowns, does this happen or does this happen? Right? So we have, if m is strictly less than n, then of course it is not just the final answer that is important, but also the basic or your basic understanding of linear algebra that leads you to this final answer, that is in fact going to be more important. So if is m less than n sufficient to guarantee that there are infinitely many solutions? And if your answer is yes, can you support your answer? If your answer is no, then you should be able to come up with a counter example. No, it is not true. So if m is less than n, is it guaranteed that the number of solutions is infinite? For which you will need to be able to convince us that yes, the number of solutions is infinite, and tell us what principles, based on what principles the number of solutions should be infinite. And if it is not infinite, if there can be a finite number of solutions, then you should be able to give an example where m is less than n, but the system of linear equations has either no solution or exactly one solution. Right? Similarly, for the second problem, if m is greater than n, you should be able to say that either if there is no solution at all, either you give an example where there can be at least one solution, or you have to be able to justify why it has no solutions. So this is the kind of thinking or reasoning that will be expected in the written test and the interview. Uh, and to and I'll maybe just wrap up here. So if you want to get more information about the written test as well as the research profiles and the kind of work we do, then you're encouraged to look at the EE department webpage, and maybe I will also post the links to the research profiles and so on in the chat window.